Hi everyone, today I want to be showing you the concept of applied force. Now, when we're talking about applied force, if you check the definition, now applied force is talking about the force required to, the force that is applied is the force exerted on the body to cause the body to move. I'm sorry for that distraction. Now, for a body to start moving, it must first overcome the force of friction between its surface and the surface it's what resting on. Now, what does that mean? Now, if you have a body, let's say you have, let's say there's an horizontal surface here, then you have a body here, right? Now, you know, for this surface, either rough or not rough, there is a what? There is a frictional force between the surface of this body and this particular what surface. Now let's say you want to apply your force in this what in this direction. Now there is a force that will oppose the motion of this body in this direction, and that force is between the surface and the surface of this body, and that force is known as what? Frictional what? Force, or force of friction. And why this one is what? F subscript A, which is what? The applied force. Now for this particular force to move this body, it implies that number one, it must first overcome this force of friction. Now after overcoming this force of friction, then it will now move the what? The body. But if it doesn't overcome this force of friction, of course you know that this body what? Will not move, right? The person will only be using up his energy and will not be doing any work on this body. So in this class we'll be considering series of cases. I'll be considering three cases here which I feel we should be able to finish. So we'll be looking at case one. Now case one, in this case, is talking about if the applied force is less than the frictional force. So we say if what? F subscript A, that's the applied force, is less than the what? Frictional force. Of course, if the applied force is less than the frictional force, or we say if the frictional force, right, is greater than the what? The applied what? Force. So what will happen? So it implies that, but don't forget that coefficient of friction is equal to what? Frictional force, right, over what? Frictional force over normal what? Reaction. So this implies that frictional what? Force is equal to what? Coefficient of friction times what? Normal reaction. So if the applied force is less than the frictional force, it implies that what? F subscript A is less than what? Mu R. That's coefficient of friction times normal reaction. Or we can say coefficient, for a frictional force, that's mil R, that's then is greater than the what? Than the applied what? Applied force. That one is what? Case one. That one is very simple. So what will happen? Of course you can easily conclude that if the what? Applied force is less, this body will not what? Move. So we can say no what? Motion. So that is what? Case one. So in this other case, we are going to look at the case whereby I call it what? Case 2. Case 2. Now in this case, if the applied force, right, is equal to the frictional force, applied force is equal to what? Frictional force. So this implies that we can say that applied force will now be equal to what? What? Mu R. So if applied force is frictional force, what will happen? Of course there won't be what? There won't be motion 2 until what? The applied force is greater than frictional force. So in this case too, no what? No motion, right? So that is what case 2. Don't forget mil R here is the what? The frictional force, but the case 2 is talking about if the applied force. So case 3 in this case, saying if the applied force is greater than frictional force, that's applied force is greater than what? Frictional what? Frictional force. So if applied force is greater than frictional force, don't forget, recall that the frictional force is equal to what? Mu what? mil r, right? So if the applied force is greater than frictional force, it implies that the body will what? Will move. But there's a force that tends that moves the body. There's the body will move with an acceleration. Why am I saying that? If F is greater than this, then it implies that what? The what? Body, right, will what? Move, right, with what? And what? Acceleration. I call it acceleration small a, right? So we can express it like, we can say this implies that if applied force is greater than what? Frictional force, right? It implies that applied force is equal to what? Frictional force, right, plus F. What does that statement mean? It implies that since it is greater, then there will be motion. So that other F, this particular F, is the force that is required to cause the body to what? To accelerate. So I say where what? Where F subscript A is the what? Applied what? Applied force, right? Then I say F subscript R is the what? Frictional what? Frictional force. And F is the force required what? To what? Accelerate what? The body. So that's the force required to what? Accelerate the body. We can now say that according to Newton's second law, according, right, to what? Newton's what? Second law, right, of what? Of motion. According to the Newton's second law of motion, we have that F is equal to what? Ma. So let me call this equation star, right? So we can say that what? F applied force is equal to frictional force, that's ma r, plus what? Plus m what? Ma, right? Also note that there's a normal reaction r for a plain smooth surface. R is equal to what? Mg. I getting? If it is not inclined, I getting it. I think that one I will show you a video that talked about that later on. So we can say that Fa is equal to what? Mil mg plus what? M what? A, right? So we can do the remaining mathematics now.